Hey everybody, Dr. Nelson here. This is a video about graphs of absolute value equations. So the first couple pages, you're going to work along with me, and then there'll be some problems for you to try, and then at the end you can see how you did. So far you've learned about linear functions, exponential functions, and then quadratic functions. And let's just draw a quick sketch of each kind. So a linear function obviously is like a line, linear. An exponential function could be like, again, relating to growth or decay. So that kind of had like a curve like this. And then a quadratic function had the shape of a U. Like this. So today we're going to look at what makes the shape of an absolute value equation when it's graphed. So if you turn the page, let's graph our first function, which is y equals the absolute value of x. Okay, and remember, the input values are the domain and the output values are the range. Okay, and the input values are going to be the x values. Let's put a little x here, and the output values are going to be the y values. Now we're going to be restricted to the input values that are on the x-axis. Okay, so our highest is going to be 10 and our lowest is going to be negative 10. So let's start off with 0. It's always good to start with 0. So if I plug in 0 in, the absolute value of 0 is 0. And let's go with, say, 2. The absolute value of 2 is 2. And how about negative 2? Well, the absolute value of negative 2 is also 2. And let's go with, say, 4. The absolute value of 4 is 4. And let's go negative 4. The absolute value of negative 4 would also be 4. So hopefully you're seeing a pattern here where no matter what the x value is, whether it's positive or negative, the output is always going to be positive. So let's say if we have positive 8 for the input, the output is going to be also positive 8. Alright, so let's graph these. So we have point 0, 0, and then we have point 2, 2, point negative 2, 2, and then we have 4, 4, and negative 4 and 4, and then 8 and 8. Now I'm going to add one more point at negative 8. So when x is negative 8, I know y is going to be also 8. So let's put a point at negative 8 and 8. So if you notice, this makes a V shape, okay? And that's kind of the signature characteristic of an absolute value function when it's graphed, is it makes like a V. So now let's carefully connect the dots and extend it in both ways. So it should look just like this, and add arrows because it extends in both directions. And there it is. Okay. So now that you understand how to graph absolute value equations, I want you to pause the video, and there's 3 I want you to graph. And then when you're done, hit play. You can see how you did. All right. Good luck. Alright, welcome back. Let's say I do with these practice problems. So the first one was y equals a negative and then the absolute value of x. So if you notice, for every input value, okay, the output value was always multiplied by this negative, right? So that's what made it always a negative. So when all the output values are negative, the graph reflects downward. So if it was just y equals the absolute value of x, it would have been just a V like the first graph. But because we have a negative sign in the front, all of the output values were negative, causing it to go downward. Alright, let's take a look at the second one. Your second problem was y equals the absolute value of x take away 2. And this is just like our first graph, except look at the y-intercept. The y-intercept is at negative 1 and negative 2, and that's the impact of this value right here. If this was, say, negative 3, well, the y-intercept would be at negative 3, and so on. And then the final one was y equals 2 times the absolute value of x. And the impact of the 2 here is it made the graph get a little bit more narrow. Okay, so again, if you compare this graph to the first graph we did, look how wide that graph is compared to this graph. Alright, so the impact of the 2 on the outside makes the graph more narrow. Alright, how'd you do?